All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome, welcome, welcome. Welcome to Unacademy NEET English. Okay. So, What's up, guys? How is it going? How is your preparation going? Let me know in the chats if I'm perfectly audible, visible to each and every single student. Everybody out there. Okay. Let everybody join. Let everybody come. And we are going to smash this particular session. I would want you guys to smash the like button and mark your attendance because marking the attendance is extremely mandatory. Okay? Yes, 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 yes. So, my dear NEET aspirants, today's session is extremely important. I don't want you guys to miss out these questions because I have selected the questions from those topics from which questions have been asked till now in the NEET examination. In the upcoming time also, or in NEET 2026 also, questions will be asked from this only. Okay? Yes. So my dear NEET aspirants, smash the like button because liking the session is extremely mandatory. And one more important thing, since I made the video recently about the controversial questions which NTA is coming up with again and again, creating the chaos among the students, you don't have to worry about anything. Okay? We don't know as of now why they are doing this, why they are putting up these controversial questions in which you have answers correct according to the old NCRT or some answers according to the new NCRT. If you get this sort of question ever in your, I would say, NEET 2026 examination, you just have to attempt any of the two options. You just have to mark the any of the two options. Okay, you'll be getting the full marks, but do not leave the question unattempted. Keep that thing in your mind. So let's dive into this particular session, my dear NEET aspirants. Everybody of you, listen to me very, very, very carefully. Okay. In this particular session, we will be revising the concepts also, but through problems. This is a pure problem session. But make sure you watch this till the end and you smash the like button. And whatever the PDF, everything, I'll be sharing that on the Telegram channel. All the updates, you can join my Telegram channel, that is t.me slash Yawar, Yawar Manzoor. This is the Telegram channel which you can actually join. Okay. So here I put up all the updates, everything in this particular channel. Okay. Yes. Now, my dear NEET aspirants, duration is going to be like 2 hours only. Okay. We'll finish all of these questions in 2 hours only. Let's get done with all of these questions in 2 hours only. So, my dear NEET aspirants, let's dive into the first question over here. And this is a very famous question. If they ask the question from the Coulomb's law, they can ask from this particular type. This is one of the types of the problem. This is one of the types from different number of types. So you can understand it like this. See, guys, 2-point charges A and B having charge plus Q and minus Q. You are having 2-point charges over here. The first one is plus Q and the second one is minus Q over here. Okay, respectively, are placed at certain distance apart. These are placed at certain distance apart. Let's suppose R. And force between them is F. They are applying force on each other as F. And how do we find the force between the two charges? K, Q1, Q2. So when we talk about the magnitude of the force, then we say Q into Q means Q square divided by, I would say, R square. F is equal to KQ square divided by R square. Now, my dear NEET aspirants, then it says that if 25% of charge, if 25% charge of A is transferred to B, listen carefully. It says 25% of this charge is transferred to B. 25% okay, of this positive charge is transferred to B. Listen carefully. In certain some questions, they might give you this is a positive charge, this is a positive charge. But here I'm taking the extreme case that this is positive and this is negative. 25 is transferred here. Now, guys, listen to me very carefully. Could you please tell me finally how much charge will remain over here? I would say QA finally. Listen to me very carefully. My dear NEET aspirants, if I say this is Q, if I say this is a pen, how much pen is this? This is 100% pen. Is it 60% pen? What happened to my voice? Is it fine? No? Is it fine? Okay. Now, my dear NEET aspirants, listen to me very carefully. Am I audible, guys? Let me know in the chats. Am I audible perfectly? Okay, okay. It's fine, huh? Okay. That's great. Now, guys, take a look. So, if I say 25% charge is transferred to this B, how much is remaining? So, if I say it is Q, 100% Q. So, 100 from 100%, 25% is transferred. How much is the remaining? 75%. 75% of positive charge. And how do we write 75%? 75% means 75 divided by 100. So 25 threes are, 25 fours are. This will come out to be 3Q divided by 4. So finally QA remains 3Q by 4. But QB, listen to me very carefully, my dear NEET aspirants. It is my negative 100% of Q. Negative 100% of Q. It is 100% charge, but what? Negative. You are adding positive. This is positive 25%. Positive 25%. Now tell me 100% of Q. Positive 25%. This is negative. 100 minus 25 is 75%. 75% of Q, but which one? What is the sign? Negative. So this will be minus again 75 divided by 100. Because 25% we write 25 by 100. 30% we write 30 by 100, 75% we write 75 by 100, that is Q. 25 threes are, 25 fours are. This will be minus 3Q divided by 4. Now, my dear NEET aspirants, then it says, if 25% charge A is transferred to B, then the force between the charges becomes. Now, finally, my dear NEET aspirants, this is QA. How much is this? 3Q divided by 4. Okay. Now, my dear NEET aspirant, this is QB. How much is this? 3Q by 4, but it is negative. Okay, now distances are. What will be the final charge between the two? F dash, that will be K. This Q1, this Q2. K Q1, Q2 by R square. This Q1 is 3Q divided by 4. This Q2 is 3Q divided by 4. Okay, divided by, I would say, R square. Now tell me, 3 into 3 is how much? 9. 4 into 4 is how much? 16. Now, Q into Q means Q square divided by this is and this K, Q square divided by R square. Now tell me K Q square by R square is how much? F. So F dash will come out to be 9 divided by 16F. This is one problem type. They can ask this particular question in the examination hall. Okay, yes, it is negative. Negative is just the sign because we are finding the magnitude only. Okay, when you are finding the magnitude only, in that particular case, you can ignore the negative sign. Okay, yes. This is one problem type. So, my dear NEET aspirants, let's suppose in the same problem pattern, if they sometimes give you this is Q. Okay, and this is also plus Q. Let's suppose if they say we are transferring 20% of charge to this, what will be the final force? How much will be QA remaining, guys? If you are transferring 20%, so 80% of Q. Now, here, this is the positive 100%. You are transferring 20%. So how much will be? 100 plus 20. So QB will be 120% of Q. So this is what happens if the charges are of the same nature. Then you will be directly adding. I hope this also you can solve from your end. Let's take a look at next question. Okay. Now take a look at this question. Let me make the diagram over here. Diagram is, I hope the diagram is visible. I hope the diagram is visible in this particular case, my dear NEET aspirants. I hope the diagram is visible. Okay. Wait. Let me make the diagram. See, 6 similar bulbs are connected as shown in the figure. Take a look, my dear NEET aspirants. These are the bulbs you have. Okay. 6 similar bulbs. Something like this. Okay. This entire system is connected to the battery. Cool. Now, this is section A and this is section B. 6 similar bulbs are connected as shown in the figure. Okay, with a DC source of 0 EMF. Okay, the ratio of the power consumption when all are glowing and when. Okay. Now guys, see. 6 similar bulbs. Similar bulbs means power of this bulb, this bulb, this bulb, this bulb, this bulb, and this bulb is same. This means the 6 similar bulbs. It says that when all are glowing, when all are working, listen to me very carefully. First portion. When all are working, when all are glowing, when all are glowing. Listen to me very carefully, guys. When all the bulbs are working, in that particular case, you have to find the net power consumption. You have to find what? Net power consumption. Guys, when the bulbs are connected in parallel, their equivalent power consumption will be P1 plus P2 plus P3. So these three are in parallel. So their equivalent power consumption will be 3P. So it will be like this. This is 3P. Now their equivalent power consumption is also 3P. You can make single bulb over here. And then this is the battery connected over here. Okay. Now my dear NEET aspirants, their equivalent is 3P, their equivalent is 3P. But their equivalent, this equivalent and this equivalent, they are in series. When you have two bulbs in series, always remember power net consumption in that particular case will be, listen to me very carefully, it is P1 P2 upon P1 plus P2. Please directly remember this. When you have in parallel P1 plus P2 plus P3, when you have in series, directly P1 P2 upon P1 plus P2. Now how much is P1 over here? 3P into 3P. So this is 3P into 3P divided by 3P plus 3P, that is 6P. Now tell me guys, this is 9P square. 9P square divided by 6P. So this and this will cancel. So 3 2s are 6. 3 3s are 9. You can say this power consumption is P1. So this P1 came out to be 3P divided by 2. So my dear NEET aspirants, when all the 6 bulbs are glowing, in that particular case, what is the net power consumption? 3P by 2. Now the next one, my dear NEET aspirants, second one. When 2 from section A, 2 from section A and 1 from section B, 1 from section B, section B is glowing. Listen to me very carefully. When 2 from this section are working, so 2 means P plus P, that will be 2P. That will be 2P. And so basically it says when 2 from this section, P plus P is 2P. 1 from this section, that is P. So this will be P. Now in this particular case, guys, what about the rest? If 2 are only glowing, you need to consider those 2 only in section A and section B. So this is P. Now tell me what is the net power consumption P2? That is P1 P2 upon P1 plus P2. That is 2P into P upon 2P plus P. Now this will be 2P square divided by 3P. P and this will cancel. So P2 will come out to be 2P divided by 3. Now what you are supposed to find in this particular question, my dear NEET aspirants, you are supposed to find the ratio. That means P1 divided by P2. Find the ratio of power consumption when all are glowing and when 2 from section A and 1 from section B are glowing. Tantre shayad tomorrow you will be having the class on Unacademy JK channel. Okay, tomorrow. Kal aapka class. Now P1 divided, kal se continuously classes. Now P1 is basically 3P divided by 2 upon P2 is 2P divided by 3. Now guys, take it in the numerator. So this will be 3P divided by 2 into P divided by 2P. P and P will cancel, so ratio will come out to be 9:4. Guys, tell me, is this clear? Is this clear? Is this clear? Please tell me in the chats, everybody out there. Is this clear? Give me the signal in the chats. Is this clear? Is this clear? And smash the like button. If you have not liked the session yet, I would want you guys to smash the like button. Yes, I'll be sharing the PDF also. Here is the Telegram channel on which I'll be sharing the PDF. t.me/Yawar Manzoor. Now take a look, my dear NEET aspirants. Now take a look, my dear NEET aspirants. Listen to me very carefully. Listen to me very carefully. Two equally charged identical metal spheres A and B repel each other with a force F. This is a metal sphere. This is another metal sphere. Okay. And these are the two metal spheres. This is A and this is a metal sphere B. Okay. Repel each other with a force F. Equally charged. If I say charge on this is Q, charge on this is Q. They are separated by distance R. Now, my dear NEET aspirants, what is the force between them? F is equal to K. Q into Q becomes Q square divided by R square. Then it says another identical charged uncharged. Then another identical uncharged sphere C is touched to A. Another uncharged sphere is touched to C. Okay. This uncharged sphere is touched to C. When it is touched to C, conduction will take place. This will basically distribute, this will share the charge with this one. So basically, okay, and then it says, and then placed midway between A and B. So my dear NEET aspirants, what happens finally? It is first touched with this and then it is placed midway. So means finally, this is the sphere A, this is the sphere C, and the sphere B. Now guys, when you touch this uncharged sphere with A, it will share the charge. So it will share half of the charge with this one, half of it will remain on this one, and here charge is Q only. Now what is the distance between the two? R by 2. This distance is R by 2. Then the net force on C is basically you are having the two spheres, Q and Q. You are bringing one more uncharged sphere, touching it with A, then placing at midway between the two. Now when you are placing this at midway between the two, so half of the charge it will half of the charge will remain here, and it will share half of the charge with sphere C because it has been touched with A. Now you have to tell me what is the net force on C. Guys, see, this sphere will repel this sphere with a force FCA. That means force on C due to A. This sphere will repel this sphere with a force FCB. That is force on C due to B. Now, my dear NEET aspirants, in this particular case, if I ask you, what is this FCA? This is the force due to this on C. So that will be K, Q1, Q2. That is Q divided by 2 into Q divided by 2 divided by, what is the distance between them? R by 2 whole square. So now this will become A, Q square divided by 2 into 2 is 4. Now this becomes R square divided by 4 because 2 square is also 4. 4 will cancel. It will come out to be KQ square divided by R square. FCA. Let's find FCB. FCB is the force due to this on this sphere. That is K. This charge into this charge. That is this Q into this Q by 2 upon. What is the distance between the two, my dear NEET aspirants? R divided by 2 whole square. Now what I can say in this particular case, this will be K Q square divided by 2 upon. This will become R square by 4. 2 1s are 2, 2s are 4. This will go in the numerator 2KQ square divided by R square. Now guys, KQ square by R square is F. You can consider this as F. Now this you can consider this as 2F. Now tell me one thing, my dear NEET aspirants. Tell me one thing, my dear NEET aspirants. What is the force on this? So that is FCA and FCB. Now guys, see, when it comes to this FCB, that is this one, FCB. What is the value of FCB? That is 2F. What is the value of FCA? FCA is F. Now, when the two forces are in opposite direction, what is the net force in this particular case? You'll be saying 2F minus F. That is 2F minus F. That will come out to be F. and direction will be towards A, because direction of net force is always in the direction of the bigger force. Is this clear, my dear NEET aspirants? Is this clear, my dear NEET aspirants? Come on, let me know in the chats if this is clear. Let me know in the chats if this is clear. Let me know in the chats if this is clear. Come on, quick. Guys, smash the like button if you are not liked the session yet. Come on, quick, 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 quick. Yes, I'll be taking the marathon on Sunday on this channel only. Now, this is the question from EMI chapter. Okay. Now let's take a look at this particular case. The concept over here involved is BLV. Whenever a rod is placed in a magnetic field, EMF is developed, and that EMF is actually BLV. Whenever a rod is placed in the external magnetic field, EMF developed in that will be BLV. And magnetic field length and velocity must be perpendicular to each other. They must be mutually perpendicular. Now see, a conducting rod PQ of length 5 meters. Length of the rod is 5 meters. Okay. If the length of the rod, this is the length of the rod, it is 5 meters. Can I say this will be the horizontal component of the rod? This is 5. This is length 5. So this is 53. What can I say? This will be 5 cos of 53. Absolutely, sir. And this component of the rod will be what? This component of the length will be what? 5 sin 53. Absolutely, sir. Now, I have shown you so many times the 53-degree triangle. If this is a 53-degree triangle, my dear NEET aspirants, we say this is 4, this is 3, and this is 5. Now, tell me, what is the value of this? This is 5 cos 53. Cos is based upon hypotenuse, that is 3 by 5 into 3 by 5. So, this 5 and 5 will cancel, it will come out to be 3. And when I say sin 53, so this is 5 into sin 53 is 4 by 5. So, perpendicular upon hypotenuse, that is 4 by 5. This is 4 by 5. 5 and 5 will cancel, it will come out to be 4. Now, this is along the x direction, I can write 3i cap. This is along y direction, I can write j cap. Now, can you write the length in vector form? This length in vector form will be something like this. Guys, L is equal to 3i cap plus 4j cap. Okay. A conducting rod of length 5 meters is oriented as shown in the figure with a velocity. Now, this rod is moving with a velocity. Velocity is along x direction, so I can write 2i cap. Without any rotation in the uniform magnetic field. What is the value of magnetic field? Magnetic field is given over here, 3i cap plus 4j cap. The EMF induced. Now see, the questioner says that the rod is moving in the external magnetic field. What is going to be the EMF developed in the rod? We say EMF developed in the rod will be simply, that is BLV. And my dear NEET aspirants, all the three must be mutually perpendicular to each other. They must be making 90. Now see, I'll be writing it like this. See, this is B, L and B. Now, how can they make 90? See, velocity is along x-axis. So means you need to take x component of the velocity. Length is along x as well as y. If I take length as x component of the length, that means this 3. And this becomes parallel, EMF will be 0. So my dear NEET aspirants, in this particular case, you must take B, L and B must be mutually perpendicular. So that's why I'm not taking x component of this, because that becomes parallel to the velocity. I'll take j component of this. Now x of this, j of this, x, that is y. X of this, y component of this. And for magnetic field, in this particular case, magnetic field is 4K. Magnetic field is 4K. For magnetic field, I'll be taking what? Z component. Now see, length along x-axis. Velocity along x-axis, length along y-axis, magnetic field along z-axis. All the three are mutually perpendicular to each other. Now guys, what is the magnetic field along z? That is 4. What is the length along y? That is 4. What is the velocity along x? That is 2. Now 4 into 4 is 16 into 2 is, we say 32 volts will be there. AIPMT 2015, important question, my dear NEET aspirants. Listen to me very carefully. A, B, C are the 3 voltmeters of resistance R, 1.5 R, 3 R. A, B, and C, 3 voltmeters. This has resistance R. This has resistance 1.5 R. 1.5 means 3 by 2 R. This has resistance 3 R. Okay. When some potential difference is applied across X value, you can imagine it like this. When a battery is connected, means some potential difference is connected across X value. Let's suppose this is the battery E. Okay. Now, my dear NEET aspirants, it says the voltmeter readings are VA, VB, and VC. It says that this voltmeter is having reading VA. Reading of voltmeter is how much is the voltage across VA? How much is the voltage across VB? How much is the voltage across VC? So this is the voltage across VB and this is the voltage across VC. Oh, are you able to understand? Oh? Okay, smash the like button if you're not like the session. So voltage across A is VA, voltage across B is VC, voltage across VC is VC. That is what we call the reading voltages. Now, my dear NEET aspirants, listen to me very carefully. Could you please tell me what is the equivalent resistance of this and this? This is 3R and this is this. This is R. This has got the resistance R. What is the equivalent of this and this? When two resistances are in parallel, their R equivalent will be, listen carefully, R1, R2 upon R1 plus R2. Okay. Now R1, R2. R1 is over here 3 by 2R. R2 over here is 3R divided by R1 plus R2. That is 3R divided by 2 plus, I would say, 3R. Now tell me, 3 into 3 is 9R square divided by 2 upon 2 into 3 is 6R. 6R plus 3 is 9R. 9R divided by 2. 2 and 2 will cancel. R and square will cancel. 9 and 9 will cancel. It will come. So equivalent of this and this, that is also R, my dear NEET aspirants. So this is also R. Now, boys and girls, if I say this is point X, let's suppose this is point Z and this is point Y. So I can say this is X, this is Z, and this is point Y. So basically, between Z and Y, this and this voltmeter is connected, or this resistor and this resistor is connected. Now, across XY, what is the battery which is connected? That is E. Now, remember one concept. Remember one concept. What is that? My dear NEET aspirants, if a battery is connected to the resistors in series, these resistors or these voltmeters, they are connected to the battery in series. We say potential difference of this battery is divided. Now, if both are equal, so this is going to give half of the potential difference to this, E by 2. Half of the potential difference to this, that is E by 2. So this potential difference is basically, that is VA, that is reading of this. So this is actually, I would say, VB, or you can say V across ZY, or you can say this is VB, or you can even say VC. Guys, see. I'm saying, sir, this is going to give, please listen carefully, this, what is the resultant of this and this? R. So this will give the half of its potential difference to this, that is E by 2. And half of the potential difference to across ZY. Why? Because their equivalent is also R. So this will be also O. This will be also, I would say, how much? E divided by 2. Absolutely. Now, when the two resistors, two voltmeters are connected in parallel, we say in that particular case, potential difference across both will be same. So what is the reading of VB? E by 2. What is the reading of VC? E by 2. So finally, my dear NEET aspirants, I can say potential difference across A is equal to potential difference across B is equal to potential difference across C. This is the answer to the question. This is the answer to the question. Is this clear? Is this clear? Come on. Is this clear? Give me the signal in the chats. Is this clear? Everybody out there? Smash the like button if you have not liked the session yet. Now take a look, my dear NEET aspirants. Listen. A charge Q is divided into two parts, Q and Q minus Q. Q is divided into two parts, Q and Q minus Q. Okay. How should the charge Q and Q be divided? So that Q and Q minus Q, placed at certain distance apart, must experience maximum force. So basically it is asking what is the value of Q. What should be the value of this Q? How this charge should be divided so that the force between the two is maximum. Listen, let's find, my dear NEET aspirants. Let's find, my dear NEET aspirants, in this particular case, force between the two. You say, sir, force is K, Q1, Q2. Q1 is Q. And this Q minus Q divided by R square. This is the force between the two. It says that what should be the value of this Q so that this force is maximum. Listen carefully. Whenever they ask you the question of this sort, in this particular case, you'll be simply saying, guys, value of F is maximum when this dF divided by dQ will be 0. This is the concept that we use over here. When differentiation of this force with respect to Q is 0, its value will be maximum. It is like when dy divided by dx, when value of y with respect to x is maximum, when differentiation of y with respect to x is 0, then the value of y will be maximum or minimum. Here I will be saying directly maximum. So at maxima and minima, we say value of the quantity is, I would say, when dy by dx is 0, at that point of time, we say either it is maximum or minimum. So simply, if you want force to be maximum, then dF by dQ has to be 0. Now, can I write it like this? F is equal to K divided by R square. Multiply this over here. This is Q into Q minus Q square. Now do the differentiation. dF divided by dQ. Do the differentiation and put the differentiation equals to 0. Because if I say so differentiation of force with respect to charge is 0, then force will be maximum. Now tell me, sir, K divided by R square is what? Now see, differentiation of Q into Q with respect to this Q you are saying. So what is the differentiation? It will be Q. Right? Differentiation of 4x is how much? 4. With respect to x now. Similarly, differentiation of this Q with respect to this Q, it will be Q minus. What is the differentiation of this? That is 2Q. Put this equals to 0. Because when you are putting the differentiation of F with respect to Q equal to 0, it means force is maximum. Now guys, K divided by R square into Q minus 2Q is equal to 0. Now take it over here, it becomes 0. So Q minus 2Q will come out to be 0. Take it over here, Q will be equals to 2Q and Q will be equals to Q divided by 2. So I believe this is crystalline clear to each and every single student. So what must be the value of Q so that the force will be maximum? That is Q by 2. Q by 2. Okay. There is a question from this current electricity chapter. A wire carries a current of 1.6 ampere. Okay. A wire carries a current of 1.6 ampere. Okay. Let's suppose this is a wire. This carries a current of 1.6 ampere. If free electrons per meter means number of electrons per unit length. Because free electrons per meter are given, n divided by L. This is given as 2 into 10 raised power 24 electrons per meter. Okay. Yes. Calculate the drift velocity. Guys, see. When it comes to the drift velocity, we say I is equal to NEAVT. This is the relation between drift velocity and current. From here, I can say drift velocity is current upon NEA. And what is this N? This is number of free electrons per unit volume. This N means number of free electrons, total number of free electrons per unit volume. Volume means area into length. If this is a wire, its length is L. A means area of cross section. How much will be the length, volume of the cylinder, volume of this wire? A into L. Now put it over here. So drift velocity in this case will be I upon. So I can say here, this is N divided by A into L, E into A. A and A will cancel. So drift velocity in this particular case will come out to be I upon N divided by L into E. Very important question is this. And my dear NEET aspirants, one thing I would want you guys to understand, if in the question it is given, if the number of free electrons per unit volume, see, if in the question it was mentioned per meter cube, number of free electrons per meter cube are this, 2 in 10 raised power 24. Then in that particular case, we'll be using this equation directly. Because this N means number of free electrons per unit volume. N by L means number of free electrons per unit length. So it is given as per meter. So current density, drift velocity in this particular case will be I upon N divided by L into E. What is the value of current? 1.6 upon N divided by L, that is 2 into 10 raised power 24. Charge on an electron, 1.6 into 10 raised power minus 20. 1.6 into 10 raised power minus 19. Is this crystalline clear, boys and girls? Tell me in the chats. Is this crystalline clear? This question is very, very important. If it is given number of free electrons per meter cube, then use this one. If it is given number of free electrons per unit length, this one. Then use this one. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everybody out there. Come on, guys. Is this clear? Give me the signal in the chats and smash the like button. Smash the like button quick. 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 Now guys, see. This is a structure over here. This is a structure over here. This is a structure over here. 24, yes. 2 into 10 raised power 24. There's a structure over here. You are supposed to tell me what is the magnetic field at the center. Guys, see. This is what we call chord. This is called the semicircle. This is also chord. And this is a straight wire. Now, whenever the current flows in a wire, it produces magnetic field. Okay. Now, here at the center, magnetic field will be produced by this wire, chord, by this straight wire, by this semicircular wire, by this wire, by this wire, this chord, and this straight wire, that is 6. Now, listen carefully. If the point lies on that line on which the wire is present, like this is the wire, current is flowing in the wire. If I ask you what is the magnetic field at this point is on the same line as wire. So magnetic field due to this will be 0 here. So in this case, magnetic field due to 2, because this is on this line only. Magnetic field due to 6. And magnetic field due to 4. It will be 0. Why? Because center lies on the axis of these wires. That's it. Simple. Now, what is going to be the net magnetic field in this particular case? Net magnetic field will be, my dear NEET aspirants, due to this, and due to this. This is a chord. Due to the chord, magnetic field is mu naught I is the current, divided by 8R. R means radius. But for this chord, what is the radius? That is 4R. So I'll be writing over here. Then plus. What is the magnetic field due to this chord? This semicircle. Mu naught I by 4R. Mu naught I divided by 4R. R is radius. What is the radius of this semicircle? 2R. Plus. Due to this chord, mu naught I divided by, my dear NEET aspirants, what is the 8R? Due to chord, mu naught I by 8R. So can I say in this particular case, what is the radius of this chord? That is R. So I'll be writing 8R. Now can you solve, okay, direction also. How do you find the direction? Curl your fingers along the direction of current. Thumb gives the direction of magnetic field. Thumb is pointing outwards. Due to this, magnetic field is outwards. Outward means dot. Inward means cross. Okay, what about this one? Curl your fingers along the direction of magnetic field, along the direction of current. Thumb is pointing outwards. So due to this, also outward. Dot. What about this? Curl your fingers along the direction of current. Thumb is pointing outwards. So magnetic field is outwards. So if all the three magnetic fields are in the same direction, that's why I made it. So here in this particular case, you can take mu naught I divided by 4R, you can take common. Then you can solve it from your end. Okay, this one. Two identical tense balls having mass m charge q are suspended from a fixed point of by threads of length L. See guys, you have got two tense balls. They are fixed from, they are suspended from a fixed point. They are having mass m and charge q. Okay, this is a question from JEE 2021. Okay, and the thread length in this particular case is given as L. What is the equilibrium separation when the thread makes angle, small angle with Q? It says that if the two charges are in the equilibrium. See, these are the two charges, my dear NEET aspirants. Okay, these are the two charges, these are the two balls. Since they have the same charge, they repel each other and they will come into equilibrium. They are asking us to find the equilibrium separation between the two, value of x. They are asking us to find the value of x. And here, with the vertical, this angle is very small. They are saying. Now, my dear NEET aspirants, I have told you this so many times. Whenever the object is in the equilibrium, it means net force on the equilibrium, net force on the particle is zero. It means upward force is equal to downward force. Right side force is equal to left side. Now see, in the downward direction, what is the force acting? mg. Okay. Whenever they say equilibrium, balance the forces. First draw the forces. Okay. Now in this one, force tension will act, because in string, what is the force which is created? Tension. If this is tension T and this angle is theta, because if this is theta, this will be T cos theta. And this will be T sin theta. One more important thing, this Q is going to repel this charge with electrostatic force. This electrostatic force is K. Q into Q means Q square divided by, I would say, distance between the two is X. So it is X square. So whenever there is the equilibrium, balance the forces. Now, my dear NEET aspirants, this force will be equals to this force. T sin theta will be equals to KQ square divided by X square. Okay, and T cos theta will be equals to mg. Now divide the two equations. T and T will cancel. Sine by cos will come out to be tan. So it will be KQ square divided by square mg. Okay, without wasting the time, I would recommend you to directly remember this equation. Without doing this stuff, I directly recommend you to do this. Now guys, it says in the question when theta is small. If theta is small, in that particular case, we say value of tan theta will be equals to sin theta. In that particular case, value of tan theta is what? Sin theta. So this will be equals to KQ square upon X square into mg. Now, my dear NEET aspirants, could you please tell me from this particular triangle, what is the value of sin theta? Sin is perpendicular. Okay. Okay. What is the value of sin theta in this particular case? Sorry, if this is theta, this will be base. This will be perpendicular. Okay. Sorry. This will be base. This will be hypotenuse. This will be perpendicular. If this is x and this will be x by 2. This is also x by 2. Now sin theta will be perpendicular upon hypotenuse. So instead of sin theta, I will be writing x divided by 2 into L. Perpendicular upon hypotenuse will be equals to K Q square divided by x square into mg. Now, take this x square over here, it will become x cube is equal. From this side, it is k q square divided by, and take this 2l in the numerator, 2l divided by, say m. Now, guys, can I write this x will be equals to 1 by 3 of 2k q square into l divided by m into g, its whole raised power 1 by 3. This is the answer to the question. Is this clear, guys? Tell me in the chats. Is this clear, guys? Tell me in the chats, everybody out there. Is this clear? Tell me in the chats. And this is one more question of JEE Mains 2020. Okay. This is simple. This is simple. You have to tell me what is the net electric field at the center. You have to tell me what is the net electric field at the center. See. You have to tell me what is the net electric field at the center. This is 2q charge. This is 4q charge. Because of 4q charge, electric field at the center will be 4e. And the direction will be towards the charge. This direction of electric field due to a negative charge is always towards the charge. And my dear NEET aspirants, due to this, it will be also towards the charge. It will be 2e. And due to this 2q, it will be, guys, 2e. Listen carefully. Due to this 4 minus 4q, electric field will be 4e towards the charge. Due to this minus 2q, electric field will be towards the charge, and how much? 2e. Due to this positive charge, electric field will be away from the charge, and how much? 2e. Now tell me. In this direction you have 4e. In this direction you have 2e plus 2e is again 4e. And this angle is 60 degrees. Why? Because this is 30, this is 30. Total is 60. Now, if you have two vectors at an angle of 60 degrees, could you please tell me, my dear NEET aspirants, in this particular case, what is going to be the resultant? If this is x, resultant will be root 3x when theta is 60. If this is y, resultant will be root 3y. If this is 4e, resultant is going to be a root 3 of 4e. So that is going to be 4 root 3e. You can write it like this also. This is the answer. This is the answer to the question. Take a look, my dear NEET aspirants. This is the question from, again, EMI chapter. This is the question again from EMI chapter. Is this clear? Oh? Give me the signal in the chats, everybody out there. Okay, smash the like button if you are not liked the session yet. Okay, now boys and girls, listen to me very carefully. In the given arrangement, okay, find the potential difference between B and D, and current in the loop are respectively. Guys, see. You have to tell me what is the potential difference between B and D. Listen carefully. This is a loop. This is the magnetic field inwards. Whenever the wire moves in a magnetic field, in that particular case, we say EMF, potential difference will be simply, that is B, L and V. B means magnetic field, L means length, and V is the velocity. Now here, I want you guys to basically break this loop in two parts. Listen carefully. That is something like this. Understand this very carefully. This portion of the loop, this portion of the loop, this, and this portion of the loop. Yes. Now, if I ask you, my dear NEET aspirants, what is the potential difference between, guys, see, in this particular case, guys, from here to here, how much is this distance? This is 2r. Why? Because it says this radius is 2r. If this radius is 2r, from here to here also, how much it is 2r? So could you please tell me what is the, listen to me very carefully, what is the length of this effective length? Guys, if this is a semicircle, if I say what is the length of this semicircle, this is the length of the semicircle. What is the effective length? Effective length is joining initial point with final point directly. This is effective length, that is 2r. If I say what is the effective length over here, from here to here it is 2r, from here to here it is 2r. So L effective in this case is 2r. And what is the effective length of this one? Guys, effective length of this one is also, this is 2r, this is 2r. For this also, this is 2r. For this also, it is going to be 2. So total is, what is L effective in this particular case? That is 4. Now, my dear NEET aspirants, what I want you to understand in this particular case, if I find EMF in this case, EMF will be B, L, B. And L effective. So B is the magnetic field, L effective is 4R, velocity is V. This is the EMF in this one. And if I say what is the EMF here, that is going to be B, and length L effective is 2R, and velocity in this particular case is V. Velocity in this particular case is V. Is this clear, boys and girls? I would want you guys to tell me in the chats. I would want you guys to tell me in the chats. BV4R, BV4R here also. So what is the potential difference between this point and this point? It is BV4R. So this is also creating BV4R. This is also creating BV4R. And my dear NEET aspirants, this is separately the potential difference of this, potential difference of this. Is this clear? Or give me the signal in the chats. Is this clear? Is this clear? Smash the like button. Smash the like button if you're not like this session. A charged particle of specific charge. Specific charge means charge per unit mass. Charge per unit mass means Q divided by M. Its value is given as 0.2 coulomb per kg. So on 1 kg, how much charge is there? 0.2 coulomb. Has a velocity. Velocity of this charge is given as, that is 2I minus 3j. Okay. At some instant in a uniform magnetic field is given as, that is 5I plus 2j. Okay. Find the acceleration of the charge. Guys, whenever the charge moves in a magnetic field, whenever a charge is placed in a magnetic field, moves with certain velocity, magnetic force acts on it. And if I say what is the acceleration of the charge, it is force divided by mass. Now see, what is the force on the charge? Listen carefully. Whenever you place a charge moving with certain velocity in a magnetic field, force on the charge will be Q into V cross B. Q into V cross B. This is what we call magnetic force divided by mass. Divided by mass. Now let's find V cross B. V cross B. Now see, how do you find the cross product of two vectors? You write over here I, you write over here J, you write over here K. You make the determinant. Whenever you do the cross product of two vectors, you make the determinant and you write I, J and K. Okay. Now, my dear NEET aspirants, what I want you to understand over here, if you have to find V cross B, now first you will be writing the coefficients of V here. What is the coefficient of I? 2, for J it is minus 3. 2 minus 3, and for K it is 0 because there is no K term. Now coefficients of B, it is 5, it is 2 and it is 0. Now you have to solve this determinant. Listen to me very carefully. First you will be solving it for I cap. Now, can I say, my dear NEET aspirants, in this particular case, whenever you solve the determinant for I cap, hide that column in which I is present and hide that row in which I is present. Now, what remains? this and this, multiply, cross multiply. 3 into 0 is 0, 2 into 0 is 0. Arey, yeah. So this will become 0. Arey, this into this minus this into this will become 0. Then minus. Now solve for j cap. In front of the j, you will be putting 0. You will be putting negative sign. Now hide that column in which j is present and hide that row in which j is present. Now what remains? 2 into 0 is 0, 5 into 0 is 0. So here also it will be 0. Then plus, now solve for k cap. Hide that column in which k is present, hide that row in which k is present. Now 2 into 2 is 4. Okay. Now solve this. So 2 into 2 is 4. Then minus. 5 into minus 3 is minus 15. So now this B cross B, listen carefully. This B cross B. This is 0, this is 0. This will be 19k cap. Now boys and girls, if I say now acceleration, acceleration is q into q divided by m into b cross b. Okay. Now acceleration will be q divided by m is 0.2 into q by m is given how much? 0.2. And what is the value of b cross b? That is 19k cap. Multiply this will be 3.8 k cap meter per second square. This is going to be meter per second square k cap. This is going to be the value of acceleration in this particular case. This is going to be the value of acceleration in this particular case. Is this clear, boys and girls? Tell me in the chats, everybody out there. This is simply the cross product of two vectors. Is this clear? Is this clear? Okay, a square of side 2 meters is placed in a uniform magnetic field of 2 Tesla in the direction perpendicular to the plane of the square inwards. Electric current is given by this and flowing in the direction as shown in the figure. Okay. Okay. You are supposed to find basically force. You are supposed to find force in this particular case. Okay. What is the force? What is the force on this loop? Guys, see, listen carefully. Remember this. If this is a loop, okay, this is a loop. First of all, leave this loop. If there is a wire placed in the external magnetic field in which current is flowing I, length is N. Whenever the current flows through the wire and it is placed in the external magnetic field, force will act on this. How much? I, L, B sine of theta. This is the force acting on the wire. Now, instead of this wire, if I say there is a square loop and current is flowing in one direction like this, either clockwise or anti-clockwise, not in two directions. We say in this particular case, net force on the loop will be 0. Keep this thing in your mind. Now, if you check this loop, boys and girls, here current is in this direction, here current is in this direction. So here net force on the loop will not be equal to 0. So here net force on the loop will not be equal to 0 in this particular case. Okay. Now, here force will act on 3 different parts of the loop. First one, second one, third one. Listen carefully. Now, boys and girls, what I want you to understand in this particular case is, let's find the force on this loop. Guys, see, that is this. If let's suppose side is given as A, how much will be this distance? If this is A, this is A. What is their effective length? So this is the effective length. This one. And this L effective is the effective length that is diagonal, that is root 2A. Now, how much will be the force? Force will be, that is I, L effective, that is root 2A. Okay. I, L effective, that is root 2A. I, L B, magnetic field B, and then sine of theta. Theta is the angle between, in this particular case, ILB sine theta. That is length and magnetic field. Guys, see, this is the length, effective length. Magnetic field is inward. What is the angle between effective length and magnetic field? 90. So sine of 90. So this force will come out to be, that is root 2 I A B, because sine 90 is 1. Cool? Yes. Okay, let's find the direction. How do you find the direction? See, place your finger along the direction of current. Guys, if the current is going in this direction, something like this, in the effective length, you'll be making the direction of the current something like this. Yes. Now place your thumb along the direction of current and fingers along the direction of magnetic field. Magnetic field is inward. Palm gives you the direction of force, magnetic force. This is the direction of magnetic force. So on this loop, direction of magnetic force is this. Okay. Now let's take a look at this, my dear NEET aspirants. Okay, second portion. How much is this? This is root 2a already. Okay. And how much will be the force on this? On this force will be same. Arey, same na, bro. That is root 2 IA into B. Yes. Now let's find the force on this portion. I and I. Here also we need to take the effective length, because when the wire is not straight, we take the effective length. So tell me, how much is this effective length? The root 2a. And if this is the direction of current, in the effective length, you'll be making it like this, not like this, like this. Yes, sir. Now tell me, boys and girls, what is going to be the force here? It is exactly like this, my dear NEET aspirants. Array, this is root 2a. So here also it is going to be a root 2, I would say I, A, and then we say B. Okay. Now. What is the direction of the force here? Guys, place your thumb along direction of current. Fingers along magnetic field. Palm gives you the direction of force. F. On this one also, I would say F. So basically, on this one, force is acting as F. On this one, force is acting as F. On this one, force is acting as F. Now, could you please tell me what is the net force in this particular case? That is 3 times of F. So I can say over here, this is 3 times of F. F will be simply, that is a root 2 I A into B, my dear aspirants. So what I can say in this particular case, that is 3 root 2. What is the value of current? A square of side 2 meters. Magnetic field is 2 Tesla. Current is 3. A is the side, that is 2. B is the magnetic field, that is 2. 2 into 2 is 4. 4 into 3 is 12. That is 36 root 2. 36 root 2 Newton is the final answer. Net force on the loop. No, sir, for last one, isn't its opposite? No, bro, it is not opposite. See, if this is the direction of current, its effective length is this. In the effective length, you'll be making the direction something like this. So basically, this current wants to go here. In the effective length, you can show it like this. Array is moving from A point to B point, either like this or like this. It's one and the same thing. In this case, this is A and this is B. The current wants to travel from A to B. Either you can show it like this, or the effective length, you can show it like this. Is this clear? Is this clear? Tell me, guys. Is this clear? Smash the like button if you're not like the session yet. Is this clear, or give me the signal in the chats? Let's take a look at this. Okay, there is a question which was recently asked in J Mains 2025. Consider a circular loop that is uniformly charged with a radius A. There is a circular loop which is having the radius R is equal to A root 2. Find the position along the positive Z direction. Find the position along the positive Z direction. Okay. Find the position along the positive Z direction. So this is the loop. You need to place it something like this. The radius is given as A root 2. Find the position along the positive Z direction. Z axis of the coordinate Cartesian coordinate system where the electric field is array. It says where the electric field is going to be maximum. Due to a circular current carrying loop. No. Due to a circular charged loop. Okay, this is a ring. This is a ring. Where is the electric field maximum? Electric field is maximum at x is equal to r divided by root 2. This is directly, remember, I have told you this so many times. Electric field is r by root 2. Now, what is the value of r? That is a root 2 divided by root 2. Root 2 will cancel. Electric field is maximum. Okay, directly. Yes, 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 yes. What else do you have? Okay, let's take a look at this one. Take a look, my dear NEET aspirants. In a coil of resistance 10 ohms, the induced current developed by changing the magnetic flux through it is a function of time, the change of magnetic flux. Guys, current versus time graph is given. You are supposed to tell me how much is the change in flux. Listen to me very carefully. Listen to me very carefully. I want you to understand. See, we say EMF according to, I would say, Faraday's law. EMF is equal to minus d phi by dt, or you write d phi by dt. Okay, you write it like this. Now, if you take it over here, this delta phi or d phi, it is going to be EMF into dt. Okay. Now, if you integrate, it will give you delta phi, change in flux. It will be EMF into dt, like this. EMF in this particular case, guys, see, this delta phi, you can write over here. Listen carefully. That will be integration of I into R. Okay. Or you can keep it like this. Now, listen carefully. If I ask you in this particular case, my dear NEET aspirants, could you please tell me what is the area under the curve? I have so many times told you area is always integration of whatever is on y-axis multiplied by whatever is on x-axis. If this is y and this is x, then integration of y dx. If this is I and this is t, you can say integration of I into dt. Okay. Now, could you please tell me area of this? Area is how much? 1 by 2 base. Base is 0.1. 0.1 means 1 by 10. Into height. Height is 4. Is equal to integration of I dt. Yes, I can say it something like this. Now, my dear NEET aspirants, what I want you to understand over here is, this is 2, 1s are 2, 2s are 4. This is 2 divided by 10 is equal to integration of. I can say I. You might have heard from the Ohm's law, I is equal to B by R. B means EMF. EMF divided by R. You can put it over here. EMF divided by R into, I would say, what? dt. Now, this is 2 divided by 10 is equal to 1 by R will come out because R is constant. Value of R is given as 10 ohms. So, this is integration of EMF into dt. Now, what is integration of EMF into dt? That is delta phi. So, this will be 2 divided by 10 is equal to 1 divided by R. R is 10 into delta phi, change in flux. So this and this will cancel. How much is the value of delta phi? Delta phi came out to be 2 Weber. Yes. Yes, absolutely. Answer is 2. So simply use this law and then use the area over here in this particular case. Okay. Yes, 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 yes. One more important thing I just want to explain over here. Okay, there is a question from flux. There is a question from flux. See, find the flux through the sphere. Guys, see, there is a rod which is placed inside the sphere which is having the charge density lambda. Always remember, according to the Gauss law, flux through the closed surface, it is Q inside divided by epsilon. Now, the point in this particular case is you don't know how much charge is placed inside. Now, see, let me tell you how do we find the charge inside. Before that, let's find how much is this length which is placed inside the sphere. There is a sphere, there is a rod placed inside the sphere. If this is r by 2, how much will be this? This is r. This will be r. Radius now. This r by 2, this is r. This would be x. Could you please tell me what is the value of x? Sir, why are you finding this length? You'll get to know. You can use PGT. PGT means hypotenuse square, r square will be equals to base square plus perpendicular square. R square divided by 2 whole square. That is 4 plus x square. Take it over here. This will become r square minus r square by 4 is equal to x square. This 4r square minus r square. This would be 3r square divided by 4 is equal to x square. Instead of square, we'll be putting the root. This would be x. So what will be the value of x, my dear NEET aspirants? So x will come out to be a root 3 r divided by 2. Because square and root will cancel, root 4 is 2. Now, if this is x, how much will be this x? So can I say 2x will be 2 times of root 3r divided by 2. 2 and 2 will cancel. So this will come out to be root 3r. Absolutely, sir. Root 3r. So means this length of this came out to be root 3. Focus exactly over here. Okay. Now, how do we find the charge inside? Guys, see, let's find charge inside. We know lambda is equal to Q divided by L, charge upon length. So charge inside will be lambda into L. Now, you need to consider that portion of the length only which is placed inside the sphere. And inside the sphere, how much is the length? That is root 3r. So you can say Q inside is lambda into root 3r. Now put this in the first equation. Tell me what is the flux through this closed surface. Q inside, that is root 3r lambda divided by epsilon. This is the flux through the closed surface. So basically, you were supposed to find the rod placed, what is the length of the rod placed inside the sphere? After that, how much is the charge occupied on that portion of the rod? Then Q inside divided by epsilon. I believe this is clear. Question from magnetism. Are you getting me? Oh? Smash the like button if you have not liked the session yet. Come on. Quick, make it fast. Find the magnetic field at the center. Guys, see, due to this wire, magnetic field at the center will be 0. Why? Because this center is placed on that line on which this wire is placed. Because this point is placed on that axis. If the point is placed on the axis where the wire is placed, then I would say magnetic field will be 0. Okay. So due to this also magnetic field will be 0. Now this much. Consider this as arc. What is the magnetic field due to an arc? Not the semicircle, not the chord. See, magnetic field due to an arc will be mu naught I divided by mu naught I by 2r theta by 2 pi. This is the magnetic field due to an arc. Now theta, this is theta. Guys. How much is this angle? 90. How much is this angle? 180. How much is this angle? 270. 270 means 3 pi by 2. So you can say over here, magnetic field will be mu naught I divided by 2r into, instead of theta, I would write 3 pi divided by 2 into, you have to. Now 2 into is 4, 4 into is 8. So this will become 3 divided by 8 mu naught I divided by pi, and pi will cancel, mu naught I. This is the magnetic. So in this particular case, magnetic field due to 1 and magnetic field due to this 2 will be equals to 0. Why? So magnetic field will be only created due to this portion, that is what we consider as wire. Okay. Yes. Now see, masses of 3 wires are in the ratio of 1:3:5. Masses of 3 wires are in the ratio of 1:3:5. And their length ratio is 5:3:1. And their length ratio is 5:3:1. So basically, I have planned 4 sessions. Guys, I have planned 4 problem sessions. Okay. Not 4, I would say 3. 3 problem sessions. Okay. So this is the first one. 2 more I am going to take, and 1 will be the replica. Okay. So make sure everybody of you join, and these problem session will cover your entire syllabus. Notes of this session will be in my Telegram channel. I hope you have joined my Telegram channel also. Okay. Now guys, see. First of all, we know, sir, resistance is rho L divided by A. Please listen to this. I would want you guys to do one thing. Multiply with length and divide with length. So this will become R is equal to rho L square divided by A into L. A into L becomes volume. Area multiplied by length is volume. So rho L square divided by volume. Now we know, sir, density is equal to mass divided by volume. Now we can say volume is equal to mass divided by density. Now put it over here. So you'll be saying, sir, this resistance will come out to be rho L square upon. Instead of V, you can put mass divided by density. Now you can take this in the numerator. It will be rho L square into density D divided by, I would say. Now guys, take a look. This is the equation. This is the resistance in terms of density and mass. So I can say resistance is equal to rho L square D divided by M. This is the equation which you are going to use in this question. Masses of 3 wires are given in the ratio of 1:3:5. And their length ratio is given as 5:3:1. Find the ratio of resistance. Okay. Now see. What is given in the question? You have got 3 wires. 3 wires are made of same material. This must be also given in the question. 3 wires are made of same material. If material is same, density and resistivity is constant for all the 3 wires. So this resistance is going to be proportional to L square divided by M. When length and mass is also only given, you can make the relation accordingly. Now resistance of first is to resistance of second is to resistance of third. You are supposed to find this ratio. That is L square by M. What is the length of first? 5. So it will be 5 square divided by. What is the mass of first? 1 is 2. What is the length of second? That is 3. 3 square divided by. What is the mass of second? That is 3 is 2. What is the length of third? 1 square. Because L square by M. What is the mass of this? That is 5. Now solve this from your end and get the answer. This is 5 square divided by 1. So it will come out to be 5 square is 2. 3 square is 9. 3 into 3 is 9 is to 3. So 5 square is 25 is to 3 is to 1 divided by 5. Now cross 5 into 25, that is 125 is to 5 into 3 is 15 is to 1. Take a look at this. Take a look at this. Take a look at this. Find the potential difference between A and B. Find the potential difference between A and B. This is point A and this is point B. You are supposed to find the potential difference between A and B. Guys, see, whenever you have to find the potential difference between A and B, you need to select the path. Select the path. This is the path from A to B. You need to select the path from A to B. So if you are supposed to find the potential difference from A to B, so select the path from A to B. This is the path. Okay, first and the foremost thing is select. When you select the path from A to B, first you write the potential of A. This is the way. So can I select the path from B to A? Absolutely. First you write the potential of A. Then, if this is the direction of current, you make this positive, you make this negative. Current always flow from higher potential to lower potential. Okay. And if this is the direction of, this is 2 ampere flowing, 2 ampere flowing, 2 ampere. Now see guys. In this direction it is 1 ampere flowing. In this direction it is 3 ampere flowing. Kirchhoff's current law says the amount of current entering the junction is equal to amount of current leaving the junction. How much is the current leaving from this junction? 1 from upper side, 3 from lower side. 3 plus 1 is 4. Means incoming current must be also 4. Here also must be 4. Now, if this is the 2 ampere current flowing something like this, this is 2 ampere. So means this is positive, this is negative. Current will flow from positive to negative. Now guys, if this is the 2 ampere coming to this junction and 4 ampere is leaving this junction, is it possible that 2 ampere is entering the junction and 4 is leaving? No. The amount of current entering the junction is equal to the amount of current leaving the junction. So means 2 ampere must be coming from this side. So this 2 and this 2 are meeting at this junction and 4 is leaving this junction. This is plus and this would be minus. Now take a look. If I say, first you write the potential of A, then guys see that this is your path. You are moving from A to B. If you move from higher to lower, from positive to negative, consider its potential drop as negative. And how do we write its potential drop? I into R. What is the value of I? That is 2. 2 into 4, that is 8 volt. So its potential difference will be considered as minus 8 volt. Why? Because you are moving from higher to lower. Then you reach the battery. This is the lower potential of the battery. This is higher potential. Bigger one is higher. You are moving from lower to higher. Its potential drop will be considered as positive. 3 volts. Then in this one, how do you find its potential drop? V is equal to I into R. I is 2. 2 into 2 is 2 into 2, that is 4 volt. And you are moving from higher to lower, so minus 4. Then here. You are moving from lower to higher. How much is its potential drop? I into R. I is 1 into 2, that is 2 volt. So it will be plus 2 volt. Guys, here you are moving from higher to lower. You are moving from lower to higher. 2 volt will be equals to VB. Final potential, that is VB. Now guys, how much is this? This is VA. Now tell me, 8 plus 4, this is minus 12. 3 plus 2, that this is 5 plus 5 is equal to VB. So this would be VA minus VB will come out to be 12 minus 5, that is 7. So it will be plus 7. Is this clear? Tell me quick. Is this clear? Is this clear, guys? Tell me. Tell me. Check. Check. potential means potential of a point. Potential of a point. Potential difference means potential difference between the 2 points. This point potential minus this point potential. That is what we call potential difference. VA minus VB. Okay. Okay, let's solve this first. This is a very good question and very important question. Now see, boys and girls, in this particular case, you are supposed to find the current over here. Do is, I would want you guys to redraw this particular circuit. Redraw. If you redraw this circuit, this and this are in series. You can interchange the position of the two. You can take it over here. You can take it over there. So you can make it like this. Okay. You can make it like this. So is there any problem with the circuit? No, no, no. Will this create any sort of problem in the circuit? No. This will not create any sort of problem in the circuit. Now see. This is 5 ohms. This is 20 volts. This is 4 ohms. This is 10 volts. This is 8 volts. You have to find the current here. Okay, see. This. What I want you guys to understand in this particular case, assume the potential at a point 0. Let. This is a trick to solve this particular question. Sir, can I assume it over here? Yes. You assume it 0. This is the way to solve this question. If we assume the potential at this point 0, what will be the potential at this point? 0. What will be the potential at this point? 0. Why? Because if this is a wire only, so from here to here it is wire only. There is no load in between, no battery, no capacitor, no resistor. So I can say potential is going to remain the same. So at every point potential is going to remain the same. Okay. Now here if this is 0, how much will be the potential here? Listen to me very carefully. If this is a battery, this is 8 volt battery. Here, potential of this point is, let's suppose 0. This is what we call lower potential. This is called higher potential. Let's suppose this is V here. You have to find the value of V. Because this is positive, this is negative. This is connected to the positive term, higher potential. We always say this potential, higher minus lower, has to be equal to this. So this higher minus this lower has to be equal to 8 volts. So V will be equals to 8 volts in this particular case. Higher potential minus lower potential is equal to how much? I would say 8 volts. Now, if this is 0, this is 8. How much will be this? Plus 8. If this is plus 8 over here, how much will be here? Plus 8, because it's the wire only. So if it is wire only till here, it will be 8 volts. Absolutely. Now, guys, if this is 0, what is going to be the potential here? Listen, I'll make it here. This is 0 volt potential. This is 10 volt battery, and you have to find the potential of this. This is higher, this is lower. You always say higher minus lower. So 0 minus V, this minus this, has to be equal to this. Now take this minus over here, V will be equals to minus. So potential of this is minus. Now similarly here, if this is 0, this is 20, here it must be plus 20. Now, my dear NEET aspirants, this is the way you guys are supposed to draw the potential of every point. Now, if you have to find the current in this current, in 5 ohm resistor, current in 5 ohm resistor, I would want you guys to take this 5 ohm resistor and find current over here. This is plus 8 volts, and here it is plus 20 volts. Listen carefully, my dear NEET aspirants. Plus 8 and plus 20. What you can say in this particular case, current is always equal to delta V divided by R. Potential difference divided by R. So you can say current is equal to potential difference. Potential difference means higher potential minus lower potential. That is 20 minus 8 divided by R. R is 5. So current in this case will be 20 minus 8. That is 12 divided by. This is the current. This is the current in this 5. Because you were supposed to find the current in 5 ohm. Is this clear? Tell me in the chats quick. Tell me in the chats quick. Okay, this is the question from J Mains 2019. Let's take a look. You are supposed to find the potential difference between A and B. This is point A and this is point B. Now, boys and girls, one important thing. This is an open circuit over here. Current will never flow through the open circuit. So remove this and remove this. Current always flows in a loop. Current always flow in a loop. Does not flow in the open circuit. So remove this and this. So you can make the new circuit something like this. Something like this. Something like this. Now guys, this is 1 ohm. This is 1 ohm. And this is 1 ohm. This is 1 volt. This is 2 volts. This is 3 volts. Now, my dear NEET aspirants, if you have to find the potential difference between A and B. Now, if this is removed, now this point becomes A and this point becomes B. Yes. Or you can make a simple wire over here. Instead of the resistance, you can make a simple wire. Now, my dear NEET aspirants, what I want you to understand is, assume the potential at 0 here. Let. If we assume the potential at this point as 0, so at this point also it will be 0, at this point also it will be 0. Now tell me, if this is 0, this is 3, what will be the potential of this side? That will be plus 3 volts. So why? Because higher potential minus lower potential must be equal to this. 3 minus 0 is equal to 3. Potential of this is plus 2 volts. Potential of this is 0 volts. Because if this is 0, here also it will be 2. 2 minus 0 is 2. If this is 0, here also it will be, oh, sorry, it is 1 volt. 1 minus 0 is 1. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, what I want you guys to understand in this particular case is, redraw again. Redraw. This portion of this portion. Okay. Now, this is 1 ohm. Okay. This is 1 volts. This is 1 ohm. This is 2 volts. This is 1 ohm. What is the potential of this? This is 3 volts. And this is point A. This is what we call the common point. Because this is connected to this also, this also, this also. Now, here you use the midpoint potential formula. Midpoint potential formula is this. This is the common point of all the 3 resistors being made. Let's suppose this is R1. This is R1. This is R2. This is R3. Okay. And this is V1. This is V2. This is V3. Potential of this is V1. Potential of this is V2. Potential of this is V3. If they say what is the value of this midpoint potential, you simply say V1 by R1 plus V2 by R2 plus I would say V3 divided by R3 upon I would say 1 by R1 plus I would say 1 by R2 plus I would say 1 by R. Now, in this question, can you tell me what is the value of this midpoint potential? V1 by R1, 1 divided by V2 by R2 plus V3 by R3, 3 divided by 1 upon. And this is midpoint potential is VA actually. 1 by R1, 1 by R2, 1 by R3, 1 by 1 plus 1 by 1 plus 1 by 1. Now solve this, my dear NEET aspirants. Is this clear? Tell me in the chats quick. Give me the signal in the chats if this is crystal and clear to each and every single student. Come on. Quick, and smash the like button if you have not liked the session yet. This I'll give you as homework. I would want you guys to do this from your end. Okay. Yes, 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 yes. Let's take a look at this question. Very important. See, in an RLC circuit, LCR circuit, the RMS voltage across the resistor and inductor are 400 volts and 700 volts. Okay. Guys, let's make the, I would say, phasor diagram of LCR circuit. We make it like this. This is the phasor diagram. This is the potential difference across resistor, potential difference across inductor, potential difference across capacitor. This is how we make the phasor diagram. Okay. Now, if you are mentioning, it says that the RMS voltage across inductor, across resistor and inductor, this is given as 400. Okay. And across inductor, it is given as 700. This is RMS. And if you see, if the equation, guys, this means RLC circuit, RLC, LCR circuit. This is the net potential difference supplied. Guys, see, this potential difference will be divided to this VR, VL, and VC. This potential difference is divided into VR, VL, and VC. Now, if I say, guys, this is what we call the peak voltage. This is what we call peak voltage, V naught. If this is V is equal to V naught sine omega t, this is called peak voltage. And if you have to find the RMS voltage from peak voltage, you write V naught peak voltage divided by root 2. What is the value of peak voltage, my dear NEET aspirants? This is 500. So root 2 divided by root 2 will cancel. It will come out to be 500. Now, guys, see. This is the peak voltage. Sorry, this is the RMS voltage. Net RMS. Guys, see. This is the net voltage. This is getting divided into VR, VL, and VC. Now, if I say this has RMS voltage 400, this has RMS voltage 700, and RMS voltage net is how much? 500. Now, my dear NEET aspirants, I can say, sir, net RMS voltage in this particular case is given as 5. Now, tell me one thing. This is V net, V RMS net. What I want you to understand is that, okay, then the peak value across the capacitor is, we are supposed to find peak value across the capacitor. Listen carefully. We know RMS voltage of resistor, we know RMS voltage of inductor, we know net RMS voltage, but we don't know the RMS voltage of capacitor. We don't know the RMS voltage of capacitor. Voice is too low. Is that so? Check now, guys. Is it fine now? Now see. Now, boys and girls, 400 and 700. Is it possible that net of 400 and... Is it fine? No. Is it possible that a resultant net of 400 and... Is it possible that resultant of 400 and 700 would be 500? No. Resultant of 400 and 300 is 500. So from this side, peak voltage, RMS voltage of capacitor has to be how much? 400. Arey bro, if this is 700, this is 400. So 7 minus 4 is how much? 3. That 3 and this 4 will be having the resultant of 5. So it is not possible this and this has the resultant of 500. So from this side, 400 has to be there. So I can say, guys, RMS voltage of capacitor is how much? 400. Now see, RMS means peak voltage divided by root 2 is equal to 400. Take it over there. Peak voltage of capacitor It is what we call 400. Root 2 is the answer in this particular case. This is the answer in this particular case. Okay. Now see. There's a question from transformers. A 220 volt input is supplied to a transformer. The output draws a current of 2 ampere. Guys, see, there is a transformer. In this particular case, input voltage is given as 220 volts. The output circuit draws a current of 2 ampere. Output current in this particular case is 2 ampere. At 440 volts, output voltage in this particular case is 440 volts. Transformer is where we give input and it gives us output. If the efficiency means neta, it is given as 80%. The current drawn by the primary winding, you are supposed to find what is the current in the primary winding. I see. Always remember, in case of a transformer, we say this neta. It is output, efficiency of a transformer is output, power output divided by power input. So you can say output power, it will be neta times of input. Power, what is the formula of power? V into I. Okay. It will be equals to neta times of, this is V into I. Okay. Output, input. This V out. 440. What is I out? That is 2 is equal to into 2 is equal to neta. Neta is 80%. 80% means 80 divided by 100. V input is 220 into current I input. This is I prime. What I want you to understand in this particular case, we say 220 ones are 220 twos. Okay. 2 into 2 is 4. 4 ones are 4 twos are 8, 4 zeros are. 0 and 0 will cancel. 2 ones are 2 fives are 10. I think this primary current, take this 5 over here, it will come out to be 5. Primary current is 5. Yes. Primary current is 5 amp. Primary current is 5. A step-up transformer operates at 230 volt line and supplies a load of 2 ampere. The ratio of primary to secondary winding. Number of turns in primary and number of turns in secondary is 1:25. Determine the primary current. A step-up transformer operates on 230 volt line, supplies a load of 2 ampere. Output current is 2 ampere. Basically, it says supplies a load of 2 ampere. That means output current in this particular case is 2 ampere. Determine the primary current. It says I input. Now, my dear NEET aspirants, what I want you guys to understand in this particular case is, always remember, when it comes to the I input, see this ratio you remember. Output current divided by input current. It is always equal to number of turns in primary divided by number of turns. This is going to be the ratio. You directly remember this. Output current is given as 2 divided by input current is equal to number of turns in primary divided by number of turns in secondary. 1 divided by. Now multiply it over here. So input current will come out to be 50. This is the ratio which you guys are supposed to remember directly. Okay. And if I say output voltage in case of transformer divided by input voltage, it will be number of turns in secondary divided by number of turns in primary. This is the ratio here. This is the ratio of the currents. Please do remember these two directly in this particular. In an alternating current, current is expressed as this. Current is expressed as 100 sine of 200 pi t. In the current, in the circuit, the current rises from 0 to peak value in time. What is the peak value of the current, my dear NEET aspirants? Peak value, this mentioned over here, this is what we call peak value. It says that this is an alternating current. It says that how much time it is going to reach the peak value. Now, if it says how much time it is going to reach the peak value, put the value of I as peak value. So this will be 100 here is equal to 100 sine of 200 pi t. Sir, what if it says how much time it is going to reach the 50 ampere? Then put the value of I as 50. How much time it is going to take 20 ampere? Put the value of I as 20. Now this 100 and 100 will cancel. So it will be 1 is equal to sine of 200 pi. 1 means sine 90. Sine 90 means sine pi by 2 is equal to sine of 200 pi. Sine 90 na? Because sine 90 is sine pi by 2 is 1. Sine pi will cancel. So 200 t will come out to be 1 by 2. So t will come out to be 1 by 4. So in 1 by 400 seconds, it is going to reach the peak value. Is this clear? Oh? Smash the like button if you have not liked the session yet. Come on. Do it quick. Okay, let's take a look at this. Is this clear? Now take a look. Find the induced EMF in the circular loop. Okay. There is a wire in which current I is flowing. I is equal to I naught into T square. Okay. And at R distance, you have placed this loop. This loop is having the radius R such that this R is much less than capital. It says how much is the EMF induced in the loop. Guys, see. Whenever we say EMF is always equal to minus d phi divided by dt. This is Faraday's law. Whenever flux changes through the loop, we say EMF is induced. EMF is d phi by dt. Okay. Now, whenever we say this flux, listen to me very carefully. This phi is magnetic field into area, B into A. Now, when I say magnetic field due to this wire at R distance, you say, sir, it is going to be magnetic field is mu naught I divided by 2R. Okay. Mu naught I divided by 2 pi. Mu naught I divided by 2 pi into R. Okay. Because this is an infinite wire, magnetic field due to an infinite wire is mu naught I by 2 pi R. Now, but what is the current over here? That is T square. I naught into T square into area. Area is A. So phi will come out to be mu naught. Instead of current, I would write I naught into T square divided by 2 pi into R. Area of this loop. Guys, flux is magnetic field into area. Magnetic field will be created by this wire at R distance and area of this loop, that is pi R square, pi into R square. Now put it over here. So EMF in this particular case will be minus d divided by dt of flux. Instead of flux, you'll be putting mu naught I naught t square divided by 2 pi. This pi and this pi will cancel. So I'll be writing 2 into R and this R square. Now whatever is the constant, take that out. Minus mu naught is constant, take it out. I naught is constant, take it out. Okay, R square is constant. Array, radius of this ring is also constant. Na? This distance is also constant, 2R. So differentiation, you guys are supposed to do d by dt of t square. What is the differentiation of t square? That is 2t. So it will be minus mu naught into r square divided by 2r. This t square is basically equal to 2t. 2 and 2 will cancel. So this will be minus mu naught I naught r square into t divided by this. This will be the EMF. This will be the EMF. Okay. Let's suppose a conducting ring of radius r. A conducting ring of radius r is placed inside a uniform magnetic field. Okay. A conducting ring of radius r is placed inside a uniform magnetic field, time varying magnetic field. And this magnetic field is this. There is a conducting ring. It is placed in a time varying magnetic field. And how much is this magnetic field? That is B naught plus alpha. Okay, B naught plus alpha. Now, what I want you guys to understand in this particular case, B naught plus alpha. And radius of this ring is basically R. Okay. Now it says what is the EMF induced? EMF is again equal to minus d phi by dt. That is minus d by dt of flux is magnetic field into area. That is again minus d divided by dt of what is the magnetic field? Magnetic field is given as B naught plus alpha t. Okay, into area. Area is basically pi r square. Now, what can you take common? Guys, in this particular case, the ring is placed in a time varying magnetic field. So this area of ring is constant. Take it out. Pi r square is out. Then d divided by dt of B naught plus alpha t. Now, it says B naught and alpha are positive constants. Now, whenever constant is in addition, its differentiation is 0. So minus pi r square. Differentiation of B naught is 0. Differentiation of alpha t will be alpha. So this is going to be EMF. This is going to be EMF. Okay. Take a look at this question, guys. The magnetic field existing in a region, this is the magnetic field. E is equal to B naught x by L plus x square. So this is the region. And there is a square loop placed. You are supposed to find what is the net magnetic force acting over here. Guys, see. This is y-axis, this is x-axis. First of all, tell me, what is the magnetic force acting on this wire? Whenever the wire is placed in a magnetic field, how much is the force acting on the wire? ILB sine theta. Now tell me, what is the force on AB? Okay. First of all, what is the value of x over here? X is 0. So I would say at x is equal to 0, what is the magnetic field? Magnetic field is variable. Put x is equal to 0 here, 0 here. Entire term would be 0, so magnetic field is 0. If magnetic field here would be 0, what is the force on AB wire? Hey, what is the value of force acting on a wire in a magnetic field? ILB sine theta. So if magnetic field is 0, force on wire AB is 0. Yes. Now see, what is the force on this wire? This AD. Listen carefully. Let's find the direction first. Place your thumb along the direction of current. Okay. Direction of current is this. Direction of current. Okay. Yes. Place your thumb along the direction of current. And in this particular case, place your thumb along the direction of current. Place your thumb along the direction of current. So this is the direction of the current, okay? And fingers along magnetic field. Okay, in this particular case. Palm is facing downwards. Palm is facing downwards. Yes. Oh, sorry. Place your fingers along the direction of current. Yes, yes. How do we apply the palm rule? Here, place your fingers along the direction of current. Thumb along the direction of magnetic field. Palm is facing what? Upwards. Okay. Now, in this particular case, place your fingers along the direction of current. Place your fingers along the direction of current. And thumb along the direction of magnetic field. Palm is facing downwards. Again. Place your fingers along the direction of current. Thumb along the direction of magnetic field. Palm is facing upwards. So direction on this, of the force on this wire is upward. Okay. Okay. And similarly, place your fingers along the direction of current and thumb along the direction of magnetic field. Palm is facing downwards. This is force. Now, on this end, this force is equal and opposite. So net force on these two is 0. So net force on these two is 0 and net force on this is also 0. Now this wire AD. And this wire AD is at length L. And X is equal to L. Could you please tell me what is the magnetic field at this distance? B is equal to B naught L divided by L plus L square divided by L square. Instead of X, you'll be putting L. This and this will cancel, this and this will cancel. So it will be 1 plus 1 is 2. So 2 times of B naught. So at X is equal to L, magnetic field is 2 times of B naught. What is the force? ILB sine of 90. Why 90? Because theta is the angle between L and B. So length is upward, magnetic field is outward. So what is the angle between the two? 90. So F will be equals to IL, instead of B, it is 2 times of B naught. Sine 90 is 1. This is going to be the net force on the load. Is this clear? Tell me in the chat. Is this clear? There is a question which was asked in NEET 2017 on the C. Always remember, if you have two parallel wires and current in this is I1, current in this is I2, distance between the two is R. If I say what is the force between the two wires, you'll be simply saying mu naught I1 I2 divided by 2 pi into R. This is what we call the force between two parallel wires. Okay, and this is force between two force per unit length. Whenever two wires are parallel to each other, current is flowing in the same direction. They attract each other with a force. This is the force. This is force per unit length. Means force on the unit length of this wire. Force on the unit length of this wire. Mu naught I1 I2 divided by 2 pi. Now guys, in this particular case, you have got 3 wires. This dot means it is coming out. This, it is also coming out. This, it is also coming out. This is A, this is B, and this is C. What I am trying to say in this particular case, this is the distance D, this is the distance D. Whenever you have two parallel wires, current is flowing in the same direction, they attract each other. It says that you are supposed to tell me what is the force per unit, net force per unit length acting on this middle wire. See, how much is the current flowing here? It is coming out of this plane, coming out of this plane, coming out of this plane. You have to find net force on this one. This is going to attract it towards itself with a force F. This is going to attract it towards itself with a force F. Now, if this is F, this is F. Could you please tell me what is going to be the resultant of the two forces? The resultant will be root 2. Because whenever you have two forces at an angle of 90, resultant in that case is root 2F. Now guys, this is net force. Now if I say this net force, it is a root 2F. What is the value of F? Mu naught I1 I2 divided by 2 pi R. Mu naught I1 I2. I into I is I square. Divided by 2 pi R. What is the distance between them? That is D. Okay, now do one thing. Multiply with root 2 and divide with 2. Root 2 into root 2 is 2. This root 2 and 2 will cancel. So answer will be mu naught I square divided by root 2 pi into d, root 2 pi into, okay. Is that clear, boys and girls? Is that clear? Okay. Is that clear, boys and girls? Now, guys, one thing, see, guys, that's all for now. Okay, I had many questions, many more questions, but I'm not feeling well right now. Day after tomorrow, we have marathon. That is on Sunday. Okay. On Monday, I'll be coming up with another 99 problem session. Okay. But that I'll let you know on Monday. On Monday. But right now, I'm not feeling well. That's why I'm ending this particular session. Otherwise, I was basically interested in taking one more hour, but not right now. So I will see you guys on Sunday, because on Sunday we'll be having the marathon, complete class 12th. Okay, then on Monday, one more problem session. Okay, so that's all for now. Thank you so much. Okay, thank you. Okay, take care and bye bye. If you are not like the session yet, do smash the like button. Take care and bye bye.